Hello everyone, I am Ch3 from IIES, the International Institute of Earthquake Engineering and Seismology, Tehran, Iran. I collaborated with one of our graduate students, Amir Hossein Firouzian, in this presentation. My talk is about enhancing data reliability in nuclear monitoring with emphasis on the characteristic curve method for reducing daily variations in geomagnetic data. The concept of anomaly detection from a time series of registered parameters, as it is shown in this slide, emphasizes on detection of anomaly regarding the statistical nature of the data. As you see in the slide, there are several local maximum and minimums that fall within the uncertainty range of the data. These local anomalies, like anomaly maximum number 1, and this minimum number 2, and also this maximum number 3, these extremums cannot be considered as a real anomaly. But for example, this one with the red arrow, this is a true anomaly because it falls behind the limits of the uncertainty of the data. This simple circumstances should be considered in detection of anomaly in every type of geophysical data, especially the electromagnetic data which are under the influence of the solar terrestrial relationship and the Earth and Sun relationship. This is a previous study returning to many years ago. As you can see, there are several components of geomagnetic data which are plotted over each other for a period of 1 year. And this is a later study which will be discussed during the presentation. These are different stations and different components of geomagnetic data. Unfortunately, we don't have any geomagnetic observatory in Iran. So in this old study, I used an earthquake within India, and the geomagnetic stations or observatories are marked with these symbols. Different components of geomagnetic data, as indicated here, are HD and Z, horizontal component declination, and also Z component, which is vertical component of the geomagnetic data. As you can see, the best result is achieved in horizontal component, then the declination, and finally the vertical component is not a good example of the implementation of this method because of the greater vertical gradient of the geomagnetic field. In this slide, again, I'm showing the horizontal components of 3 different stations, and also there are 3 different components within each station. I'm sorry for the notation of the numbers because I didn't have access to my original files due to some hardware problems. This is the H component on the whole data for each station and each component. It is maybe 10 years of data, and you can see the gradual variation of the geomagnetic data for these components and these stations. And also there are some abrupt changes that can be due to instrumental problems. Here the D component and also the whole data for D component of the geomagnetic data in these 3 stations and 3 different components, and also the Z component and the whole data for the Z component. Finally, I use the method to digitize the characteristic curve and exploit it from this uncertainty band of the data, which is composed by overplotting the geomagnetic records for 24 hours per day and for a 1 year period. This slide shows the result. The left panel shows the original data, raw data, and the right panel shows the processed data. It means the characteristic curve is reduced from the original data. As you can see, sorry again for the Persian numbers instead of English. You can see the numbers differ in the vertical axis of the diagrams because in the right one, the processed data vary between 300 and minus 600 nanoteslas. And this is the final result of that old study, which shows the location of the anomaly regarding the origin time of the earthquake. Of course, in the future study, the method improved and the results are better compared to this old one. EGU 2022. Here, the characteristic behavior of the geomagnetic field in different stations and different components, which are X, Y, and Z in this case. And these stations are shown. Again, the uncertainty of the data is calculated, and the location of the anomaly regarding the origin time of the earthquake can be seen here. Geomagnetic anomaly before the earthquake. So we could not conclude that this anomaly is really related to the earthquake as a precursor or not. We just reported that there is an anomaly before the earthquake. In this part of the presentation, I want to introduce our newest work with Amir Hossein Firoozian about swarm satellite. Swarm satellite is one of the satellites that launched for geomagnetic studies, and of course also other parameters. We use the geomagnetic data from swarm satellite, its magnetic sensors. One of the most important issues regarding the swarm satellite data is that it should be the IGRF, or global magnetic model, should be reduced from the raw data. If you plot the swarm satellite magnetic data, you end up with this plot at the right upper side of the slide, and no variation can be seen in this plot. If you subtract the IGRF from the data, then you will see that there are some changes in the data, and exactly the same circumstances that took place in ground magnetic station also can be seen in this satellite data. And again, you can see the characteristic curve and the uncertainty band of the data in these plots. Actually, the geomagnetic data from swarm satellite seems like this if you plot several days on the same chart. There is a significant difference between working on satellite magnetic data and ground-based magnetic data, because in ground-based geomagnetic data we work with the data which have time, but in satellite data we encounter a problem which relates to the latitude, because the sensor is moving, and we should take in account the latitude of the satellite in each orbit when it rotates around the globe. In upper and lower latitudes, I mean in this slide, greater than about 50 and also less than about minus 50 degrees, the geomagnetic field is very unstable, and we cannot use these data for our purpose to study the geomagnetic data seeking earthquake precursor. So we just we cut the data and just focus on the part of the geomagnetic data that we can use. Amir Hossein did a great job and studied the whole catalog of the swarm satellite data, and this is the result of his work on the B or magnetic field in N, E, and C components. It means north, east, and central component of the swarm satellite data, which are shown in this slide. And in this slide, again, we can see the application of the characteristic curve. The same principle is also applied on the data, and we can see one of the records apparently deviates from the whole data, which is about some 25 days before the earthquake, which is shown in the color scale on the right side. This is related to the recent Myanmar earthquake with magnitude 7.7 on 28 March 2025, and this is a clear anomaly before this great earthquake. If you want to plot the satellite data directly, we will see such a plot, because each of these bars are the recordings of the satellite in one of its orbits, and it takes time from one orbit to another for the satellite to be again in the area of our interest, which is the study area of the earthquake zone. Of course, this zone is defined by a relation introduced by Dobrovolsky, which is going back to 1975. And if you want to just plot the values without attention to the time, the right side panel will appear, and the earthquake can be seen in the left panel by a blue dot. So we can see there are two anomalies. We believe that because of our experience in previous years, the geomagnetic precursory data shows that the anomaly always is in reducing the geomagnetic field values, not in increased values. So we believe that this anomaly can be considered as the earthquake precursor. And also the geomagnetic storms are studied in this case, and no geomagnetic storms has been reported in the relevant days, 2019, I think, yes. They reported an anomaly 27 days before the earthquake, which falls within the uncertainty band of the data, and we believe that the true anomaly is this one, which is about 33 days before the earthquake. And if you want to plot there the different components, we can see the situation of the anomaly before the earthquake, and this is the same in all plots, in all components. I hope to have finished on the right time. Concluding my presentation, I should say that this method not only is useful for earthquake precursory studies, but also it should be taken into account in any kind of monitoring study on any kind of geophysical data which is under the influence of the Sun-Earth relationship, because all geophysical data which is recorded as an observatory, I mean 24 hours, these data are under the influence of solar terrestrial influence. So I wanted to introduce this method and emphasize on its importance to CTBT community to take it into account when working on observatory data of any kind. Thank you very much. And I wanted to thank CTBTO to support my attendance on the conference. Unfortunately, due to current situation in Iran, I couldn't attend in person, but I tried to do my best to present my work and also my colleagues' work virtually. And I would like again to thank everyone in CTBTO and SNT 2025 for their helps and supports. Thank you.